Ever since it started operations, the James Webb Space Telescope has provided us with incredible images of the universe. These images are some of the clearest and most precise windows to the cosmos astronomers have ever had access to. With each passing day, the Space Observatory increases our understanding of the universe as a whole. NASA has revealed that the telescope does more than just explore the cosmos. It is also incredibly powerful at providing us with accurate images of our solar system. In the latest release, NASA has revealed some unexpected images of Jupiter, which will blow your mind. Let's take a closer look. Widely regarded as the successor to the Hubble Space Telescope, the James Webb Space Telescope is an infrared space observatory that launched on December 25, 2021. The telescope took around $10 billion to research and manufacture, making it NASA's largest and most powerful space science equipment. It will be used to probe the cosmos in an attempt to uncover the history of our universe, from the Big Bang to alien planet formation and everything in between. It took the telescope around 30 days to travel nearly 1 million miles to its permanent home, called the Lagrange point, which is a gravitationally stable spot in space. The telescope then moved on to Lagrange point 2, where it will stay in orbit around the Sun for the remainder of its mission. This orbit will allow the telescope to stay in line with Earth as it orbits the Sun. This has also been a popular spot for several other space telescopes over the years. These include the Herschel Space Telescope and the Planck Space Observatory. The telescope has undergone a series of science and calibration tests, which include sun shield deployment, instrument turn-on, telescope deployment, and telescope alignment. The Space Telescope Science Institute states that it took nearly 6 months after deployment for the observatory to start sending back images. The pictures taken by the telescope so far have allowed us to enter a new era of astronomy. The project is a product of an impressive international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. According to NASA, the development of the telescope involved over 300 universities, organizations, and companies from 14 countries. The telescope is expected to stay functional over the next decade. According to NASA, the James Webb Space Telescope will focus on 4 main areas. It will look to study the first light in the universe, the assembly of galaxies in the early universe, the birth of stars and protoplanetary systems, and planets. The telescope's expected to study the early stages of the universe after the Big Bang started the universe as we know it today. In the first stages after the Big Bang, the universe was a sea of particles such as electrons, protons, and neutrons. This is why the light was not visible until the universe cooled enough for these particles to begin combining. Another thing the JWST will study is what happened after the first stars formed. This era is called the epoch of reionization because it refers to when neutral hydrogen was reionized by radiation from these first stars. Looking at galaxies is a useful way to see how matter is organized on gigantic scales, which in turn gives us hints as to how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years, and one of the JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways that galaxies form and assemble. The last decade has seen vast numbers of exoplanets discovered, including with NASA's planet-seeking Kepler Space Telescope. JWST's powerful sensors will be able to peer at these planets in more depth, including imaging their atmospheres. Understanding the atmospheres and the formation conditions for planets could help scientists better predict if certain planets are habitable or not. When the James Webb Telescope was still being planned more than 20 years ago, no planets were known to scientists other than the ones that exist in our solar system. Since then, astronomers have discovered thousands of planets orbiting other stars in our galaxy. A significant part of the telescope's mission involves the study of the atmospheres of these planets. The wavelength coverage of the telescope is particularly tuned to help in studying molecules in exoplanet atmospheres and the low infrared background from space. This gives it a massive advantage over telescopes based on Earth. The telescope can use 2 different techniques to accomplish this task. One takes advantage of the fact that planets can pass in front of their parent star, creating a dip in the light we can observe. By analyzing this light and breaking it down by wavelength with great precision before and during this transit, the telescope can probe the planet's atmosphere to unveil what molecules it consists of. The second technique makes use of a special instrument called a coronagraph to block the light from the parent star to enable direct imaging of the planet and studying its atmosphere or surface. This mission is a particularly exciting one for the telescope because it can help identify any potentially habitable planets in the distant universe. If any suitable planets are found, they could warrant further investigation by one day sending many space probes to take a closer look. The ultimate goal of the mission is to find a planet that is similar to Earth, but scientists estimate that it would require a very lucky combination of circumstances. The James Webb Space Telescope will also likely study gas giants similar to Jupiter and Saturn, and even ice giants such as Uranus and Neptune. There are several odd and extreme planets among Webb's early transiting targets, including WD 1856b, a giant planet that orbits a stellar corpse, and HD 80606b, a planet whose orbit looks more like a comet's elongated, lopsided loop around its star than a planet's more circular path. Those extreme systems could contain clues about how different kinds of planets form and survive, and by surveying the gases clinging to a multitude of worlds, JWST will help scientists understand how a planet's size, temperature, and evolution are linked to its climate and other characteristics. Many of the telescope's early observations will target hot Jupiters, a class of planets we don't see in our solar system. Whipping around their stars in mere hours or days, these giant worlds are among the most common types of planets discovered so far by astronomers. The researchers will put all four of the telescope's instruments through their paces, and they will look for the ratio of carbon and oxygen in the planet's atmospheres, which contains information about where the planets formed. Another intriguing type of planet that we don't see in the solar system is the super-Earth or the mini-Neptune, worlds that are bigger than Earth and smaller than Neptune, like Gliese 486b, GJ 1132b, and K2 18b. Finding out whether these planets have atmospheres and what those atmospheres are made of is crucial for determining whether they might be habitable. Whether such worlds could be habitable hinges on where and how they formed and how they evolved. Some could be the stripped cores of former Neptunes, which dims the odds for habitability. Others sit right on the border between large rocky worlds and small gas worlds, a transition that scientists don't fully understand. Other early targets include hot, rocky planets that are snuggled up to their stars, making them more like roasted lumps of charcoal than overheated puffballs. On these worlds, which include 55 Cancri E and K2 141b, clouds made of rock and minerals might rain lava, creating a landscape that defies imagination. JWST will also target each of the 7 rocky, roughly Earth-sized worlds in the TRAPPIST-1 system. These planets orbit a small nearby star about the size of Jupiter, and 3 of them are temperate. TRAPPIST-1e, among the early targets, offers perhaps the best chance of detecting Earth-like conditions, while TRAPPIST-1c, another early target, is closer to its star and probably Venus-like in temperature. While JWST will transform our understanding of the worlds that populate our galaxy, the telescope is unlikely to spot signs of life, unless scientists are extremely lucky. That type of observation is just on the edge of the telescope's capabilities, and it would require an oversized chunk of observing time. Detecting distant alien biosignatures means looking for combinations of gases or chemical elements that scientists wouldn't expect geologic processes alone to produce. And while astrobiologists have some idea about what we could look for, methane, ozone, and other metabolic byproducts, it's not clear what form alien life signatures might take. Recent images revealed by NASA prove that the JWST can do more than just peer into the deep universe. It can also help us study our own galactic neighborhood. On July 12th, the James Webb Space Telescope team unveiled the mission's first science quality images, a handful of amazingly detailed shots of the deep and distant universe. The team released some tantalizing photos of Jupiter, highlighting the $10 billion telescope's ability to study targets much closer to home. These images of Jupiter, combined with the others released previously, demonstrate the full grasp of what Webb can observe, from the faintest, most distant observable galaxies to planets in our cosmic backyard that you can see with the naked eye from your actual backyard. The Jupiter photos were captured during Webb's commissioning period when mission team members were calibrating and vetting the observatory's 4 science instruments and other systems. The telescope was designed to peer deep into the universe's past, studying the first stars and galaxies ever to form. But the infrared observatory is a highly capable multi-purpose tool, and astronomers will use it to investigate a variety of cosmic objects and phenomena, including some in our solar system, as the Jupiter pictures show. Those photos are quite detailed, capturing the giant planet's cloud bands, its famous Great Red Spot, and even some of its faint rings. Several moons are visible in the images as well, including Europa, a frigid world that harbors a huge ocean beneath its icy shell. The Webb team also observed several asteroids during commissioning, testing the telescope's ability to study fast-moving targets. Scientists are surprised that the telescope was able to deliver such clear and bright images of objects in the solar system. They plan to use the observatory to study more planets and objects closer to home in the future. If you found the video informative, you may also like this other one, which looks into a strange radio signal that scientists found originating from space. Do you think the James Webb Space Telescope will finally help us find alien life? Please share your thoughts in the comments section below.